Hello everyone, this is Physics 103. This is on nuclear physics, and here we are going to learn about the second type of radioactive decay, which is beta decay. So beta decay has three kinds. You have beta minus, uh, beta plus, and this electron capture. So these three kinds of beta decay is produced because of the weak nuclear force. Or sometimes they call it the weak interaction. So let's look into detail what is the beta minus decay. So beta minus decay involves the transformation of a neutron so you have a neutron inside the nucleus. So the neutron transforms into a proton, and by conservation of charge, there should be a negative charge added into the transformation. So you should have a beta minus particle. And another particle, which is the antineutrino. So the antineutrino is written by this Greek letter nu, and for antiparticles we will write a bar above the symbol. So what is this beta particle? So this beta particle is simply an electron. So that's an electron with minus E charge, and combined with the proton with positive E charge, they both satisfy the conservation of charge. So you might be wondering why the need for this another particle, which is the antineutrino. Doesn't this proton and electron already satisfy the conservation of charge? Or in other words, is why do we need an antineutrino in the process? So an antineutrino was first theorized because when unstable nucleus emits a beta particle, the beta particle occurs in energy within a continuous spectrum of energies. So what do we mean by continuous spectrum of energy? So compared to the alpha decay, wherein the unstable nuclei just releases an alpha particle, we can measure in a definite value the energy of the alpha particle. So we are sure that we can measure the definite value of the alpha particle. But this beta particle occurred in continuous spectrum of energy. So meaning, if you want to say have different measurements of energy. So for example, this is different numbers of experiment. So it measured energy here, 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 here. So it doesn't give a definite value of energy as it leaves the nucleus. So a continuous spectrum of energy can only happen if there is another particle that is sharing with the beta minus particle. So there should be at least two particles sharing the release of energy, so that it's not always definite. So sometimes it's high, sometimes it's low, but the important thing is there is another particle contributing to the continuous spectrum of energy. So they postulated the existence of the antineutrino, and in 1953 two scientists, Frederick Rines and Clyde Cowan, measured the existence of the antineutrino. So the antineutrino must be included in is actually included in the beta minus decay. So for example, here we have an unstable carbon 14 and it undergoes beta minus decay. So when one neutron from the carbon 14 transmutates into a proton, its atomic number will be increased. So in its nucleus, one neutron is converted to a proton. So it will have atomic number of 7. And upon the decay, you will release a beta particle, which is an electron, and this is 14 too, and a antineutrino.